Hello and welcome back. Today I want to talk about sed. Sed is the stream editor for filtering and transforming text. So I'm using the echo command with the E option so that I can use \n as new lines, so I can separate the records with new lines. So I have new lines in between these records, and I have 3 fields and they are separated by commas. I'm going to send all this using standard input to sed file 1. Let's take a look. Okay. And I'm going to clear the screen. Let's replay that. And the S subcommand, I'm just going to call these commands actually. This will attempt to match regular expression against the pattern space. If successful, replace that portion match with replacement. So here is the text we want to match on to replace, and then we specify the replacement here. And note the 3 forward slashes that separate all of these blocks. Okay, so let's paste this, and here we have the pattern. And so the pattern consists of a bracket expression specifying a digit between 0 and 9, and then we have the plus symbol that symbolizes one or more of what precedes it, and then this whole block of code is made into a group by surrounding it with parentheses, and then the plus and parenthesis symbols are escaped by backslashes, so they are not mistaken for literal characters. And then we have the dash, so that's the pattern, and then it is replaced by the back reference 1 as symbolized by the backslash and 1, and this will replay the first the code that is contained in the first group of this S command. So rather than typing all of that out again, I just use the back reference 1 to refer to that code, and then I'm surrounding this with literal parentheses. So the objective is to match on every single number in the third field, and then remove the dash character, and then surround each one of these numbers with the parentheses. So this regular expression will match every single number in the third field, and then replay it with the back reference 1, and then surround it with parentheses while omitting the dash character. Now let me show you how awk does this. Just to contrast the way that both of these characters work. So the capital F option specifies the input field separator as the comma, while the begin pattern specifies the output field separator as the comma as well. Then we have an action statement. The gsub function has a parenthesis that starts here and then ends here. And then first it specifies the regular expression, and then we have a comma, and then you can see here, the literal parentheses, and then the substring function is specifying the second substring of the third field, and then we have a comma, and then this specifies the third field. This ends this gsub function, and we have a semicolon, and then we are simply printing this. But you can see that the sed command uses a lot less code to get this done rather than the awk command, but awk has more capabilities than sed does. So sed is a stream editor that is used for filtering and transforming text, but it is sed's ability to filter text in a pipeline which particularly distinguishes it from other types of editors. Let me move on with the tutorial. I'm going to clear the screen, and we have the etc directory, and we want to list this, but we're using the recursive option to unpack all of the directories and subdirectories and all of their files. There's a lot of output, but let me clear the screen. But here we are using sed to show us everything that matches the pattern as specified by the / here, and then printing that. So it acts as grep. But sed can do more than grep, because sed can transform text. So we are transforming the lowercase t to the uppercase t, but by default it will only transform the first match. If we want to transform all of the matches, we use the global command. So that will transform all of the matches. So transforming text. Let's move on to a practical example. I'm going to clear the screen. Using the copy command to act on the output of the command in between the parenthesis headed up by the $, and then we are renaming this file main file. But inside this we have the find command running as root against the etc postfix directory, and then we are looking by name for the main.cf file. And this is a configuration file that has a lot of commented lines, a lot of blank lines. I don't suggest removing any of those commented and blank lines, but let's just play around with sed a little bit here. These two commands are separated by semicolons. So the S command is removing 0 or more of any character that begins with the comment character. So this is replaced by 0, nothing. And the global command will do this throughout the entire document. And then this pattern specifies nothing in between the anchors that symbolize the beginning and the ending of the line. So nothing, there's nothing occurring between the beginning and the end of the line is the pattern. And then we are deleting that with the D command. So a lot of progress, but we still have a gap here. Let's clear the screen and let's take a look at why that gap occurred. Echo this. So we have a line that begins with a blank space, and then we have a line that begins with a comment character, and then we have an empty line that we created with 2 new lines, and then we have 3. So we have excuse me, I'm just going to clear the screen and pretend like that never happened. Okay, now here we have the pattern that specifies at the beginning of the line we have the comment character, and then we are deleting that, then semicolon, and then this other pattern that specifies an empty line, then we're deleting that as well. But we did not delete the line that had the blank character in front of the 1. So here we have the same code that we ran before. Let's remedy that. So this S command will replace 0 or more spaces with nothing. So remember, the backslash lowercase s symbolizes space. So now we will remove that gap. I just wanted to highlight the difference between empty lines and blank lines. Empty lines are 0 characters long, caused by no data at all, while a blank line consists of space characters. So if you press the space bar in a file while you're editing your file in Vim, you would have blank lines. So that's why I put that blank space in front of the one for this lab. But let's move on to making your sed commands persistent as functions in the bash rc file. So let's take a look here, and here we have the function name. We're calling this clean file, and then here are the parameters. There are no parameters, but these need to be here for this to work. And then we have the curly braces, and then the statement consists of the sed command. We're using the in place option to change the data, to actually transform the data in the file. This option has a feature that allows me to back up the original file and then specify its presence actually by putting a suffix at the end of the file so that I can mark it for later. So the original file will have a .cp at the end of it, and here we have the sed commands that I was talking about before, and in between single quotes. The $1 means user input. So I'm going to press capital Z to save and exit. And let me show you, let me mention the source command. It will read and execute commands from the file name in the current shell environment. You could either use the dot or the source to invoke this, but if this function was brand new, if I had just wrote this in the file, I would have to source it to be able to use it in the current environment. So here I can call it by name and then use it against the main file. So the main file has been transformed while the original file has retained its documentation. So again, the in place option will permanently alter the file, so be very careful, and making a backup might be feasible. Let's clear the screen. Let me tell you about the quit command. The quit command will immediately quit the sed script without processing any more input. So we're saying at address 3 we want to quit and then print. So this would be address 3, because this echo command will echo 4 lines. So it wants to quit here, so it only prints 2 lines. So these are little exercises. The N command will read or append the next line of input into the pattern space. So let me explain what the sequence command will print a sequence of numbers. So just very simply 1, 2, 3, 4, and these occur on each separate line, and these are separated by new lines. So what the sed command will do is it will save this to the pattern space, save this to the pattern space, and then when it gets to the third address, we want it to substitute any character with X. And then it will just simply print 4 because nothing is specified. So interesting. And here, with the first step method, we are specifying every third will be replaced. Here, every second will be replaced. And then finally, and these are prelims to, I have more complex labs, but these are just appetizers here. So here I'm sequence 3. So then at address 2, I want to execute this array of commands. And so I'm substituting 2 with X, and then I'm printing. And so because I've used the silent option, I've suppressed automatic printing. And I've just printed what I've matched. Section 2 covers regular expressions. So when you're using the regexp extended option, you do not have to use the backslash to escape the following characters. So the question mark means 0 or 1 of what precedes it. The plus symbol means 1 or more of what precedes it. The asterisk means 0 or more of what precedes it. The pipe character means or. The curly braces mean repetition, and then the parentheses mean grouping. So speaking of the dot character, I'm just grepping for anything. So everything needs to be matched. And so here I'm looking for 1 or more E. And here I'm looking for A, and then 1 or more E. Okay, now we are using the question mark character, and we're saying 0 or 1 A, and then 1 or more E. Okay, now we're using the asterisk character, and we're saying R, and then 0 or more E. So 0 or more of what precedes it, and then just simply R. Okay, so now we are looking here. We have 2 commands. Okay, okay, and we have a substitute command that deals with the literal value of delete. I mean, of the asterisk. And so it deletes the asterisk. Hold on, let me remove that. And then we have what we had before, which is R and then 0 or more E. Wait, I guess I really did need that /, didn't I? So this is a way for you to literally match on a asterisk character rather than having it be considered as a quantifier. So let me move on. Let me clear the screen. I'm going to circle back on actually why that / is necessary. That's a little bit odd, but let me move on to the dot character, which means any one character. So any character. So any character that comes before at here. And here I just want to remind you, because that you have to use the / to escape the dot character to match on a literal dot. Here any character that comes before the literal dot is matched. And these are good exercises because you will have to match on literal dots and then also use the dot character in your equations. I'm going to clear the screen and let's take a look at repetition. Okay, so here we have word constituent character and then a group of 4. So words that are 4 letters. Here, look. That's one group of 4 letters. That's one group of 4 letters. That's 2 groups of 4 letters. Now let's use that in a said. Be nice if I use that. Okay. So here we have, see, we have 2 matches. But in the structure of this repetition arrangement here, the first number is the least amount of characters in the group, and then the second group of the second number actually is the largest that the group can be. So this is the smallest amount of characters that the group can have, and then the largest amount of group of characters that the group can have. And if you remove the second number but you leave the comma, then that means 4 or more. Okay, so now it is matching on words that are 4 or more characters. But you see here that we are matching on a group of characters that is at least 4 characters, but at most 8 characters. So 4, and then 5 will be matched, and then 8 will be matched. Let's go move over to the sed command. Let's see. So now we only have 1 match because that's 1 match of 8 characters. But we also have a match of 4 characters or 5, whatever. Now let's clear the screen. Let's move over to bracket expressions. Bracket expressions specify the possible characters. So this will this has F and C in the bracket expression, and so this will match on either fat or cat. Here we can use a hyphen to specify a range of characters. So you could say A to Z. Well, that would be the same as using A to C, because actually no. You would have F and then E. So that's a way of you specifying a range of characters. And I'm going to clear the screen. And so here I have a group, and I'm using the pipe character in the group, and I'm specifying this or that. So either lowercase t or uppercase t will be matched. If I don't have a group and I use the or character, that would mean either a literal t or the word the. Here's another exercise here. Let's take a look at this. So either T or E or R, a group of either of those characters, that is at least 2 characters long, but at most 3 characters long. So here I have TRE, that's one group, and then I have ET, that's another group. And so here you can see it's matched twice because there are 2 groups here. And so here we have one R and then a group of at least 2 or at most 3 E's. So 2 E's. So you see it matched once. Let's move on. Let me show you that. Let me clear the screen. We should replay the last one. And so now we have R and E in a group. And so we're specifying a group of RE that is at least 2 of these sequences long, or at most 3 of these sequences long. So here are 2 sequences and then 3 sequences I put here specifically for this lab. So that's repetition. That's repetition. So very, very interesting. The anchor characters are the caret, which symbolizes the beginning of the line. So capital T at the beginning of the line is matched here. And so here we have a literal dot character at the end of the line, as symbolized by the other anchor character, the dollar symbol. Let's grab, and so let's make that happen with sed. And here is a short, I'm going to clear the screen. Here's a short lab having to do with back references. So here I'm echoing AHA, excuse me. And then I have a group which looks for A, and then I have a bracket expression that specifies H, and then I use the back reference to refer to the code in the group, in group 1, and I've matched all 3 characters. So a pattern consists of a group containing A and a back reference to that group. So the back reference N, where N is a single digit, matches the substring previously matched by the nth parenthesized subexpression of the regular expression. So you could have a lot of back references, but I'll move on to section 3.